I'm doing 58. Because I think I did that one on another class. So I'll do this one. Again, but anyway, guys, it's the exact same thing. There's really no difference from this problem to the other problem. The only thing is you got to factor. And if you're having trouble factoring, replace sine with x. And say, OK, how do I go ahead and factor a problem just like this? Well, going back to your factoring skills, does that work?
Yes.
So now I'm just going to, since I replaced sine with x, I'm just going to go back and replace, or I replaced x for sine. Now I'm just going to replace sine back in for x. So 2 sine of x plus 1 times sine of x plus 1 equals 0. Huh? Oh, it was theta, wasn't it? Sorry. Should have used theta. I mean, it's just a variable. It's not really big of a deal, but yeah, I mean, it's just a variable. This is just theta's just part of your Greek alphabet. So we usually use theta a lot with angles and trig. Is everybody OK with that? And then we just do exact same thing. Pythagorean or zero product property. I'm going to save my steps here. Is everybody OK with my solutions? Is everybody OK with my solutions? OK. Now we're going to do just like we did before. However, it's not asking us for all the solutions between 0 and 2 pi. It's asking us for all of the solutions. However, we're going to want to use the same process we did before. We're going to want to find all the solutions between 0 and 2 pi first. So when is the y-coordinate equal to -1? Well, that one's pretty easy. Do you guys agree with me? That's the only coordinate point when x is going to equal -1? Right? So a lot of times when I'm doing all the solutions, I like to write mine. Rather than writing it like this in this horizontal view, I like to kind of write it in a vertical view. Because remember, when you're using all the solutions, a lot of times you're going to be using that n, correct? So I'm going to write x, so what negative x equals 3 pi over 2. Now, I'm not going to add n yet. I'm going to find all the solutions before I add any n. So then we look at when does sine equal to -1/2? Well, when does it equal to +1/2? Once I know when it's +1/2, I just know that the sign is negative in the lower quadrants. So sine is going to be +1/2 at 30 degrees, or pi over 6. Well, halfway, all the way around the circle is pi, right? So half of that would be pi halves. So pi halves, 2 pi halves, 3 pi halves, 4 pi halves.
Okay, and then what's that coordinate point at the bottom for? Is when x equals
Y sine equals -1. Y is the y coordinate. Sine is the y coordinate. So at this coordinate point, I have square root of 3 over 2, comma, 1/2.
sine equals -1/2.
Well, I'm not there yet. So does everybody agree sine equals 1/2 here for this reference angle? However, we're looking for when it's negative. So we're going to use the reflections right here. Pi over 6, pi over 6. This point and this point. Do you guys agree with me? These 2 points are the exact same coordinates, but sine is going to be -1/2? Yes? So let's figure out what are these coordinate points. Well, halfway around the circle would be 6 pi over 6, because it's in terms of 6. 6 pi over 6. So therefore, this is going to be 7 pi over 6. And then all the way around would be 12 pi over 6. But this angle is going to be one short, so it'd be 11 pi over 6. So my answers are going to be x equals 7 pi over 6. And x equals 11 pi over 6. Now, once we have this so we know this is our answer. To get to the next answer, I'm going to have to go how far around my circle? How far around my circle do I need to go? if here's my answer, if I go around once, which is a distance of 2 pi. And how many times can I go around 2 pi? N. Here's one solution. To get to the next solution, though, I got to go all the way around, again, 2 pi. So all of these are going to be added 2 pi n. Because none of the solutions are like related to each other as far as an even distance. So you're going to add 2 pi n to each of them. Any questions? Yes.